All right, I have a Refrigeration freezer where the evaporator coil is freezing up. So the customer has unplugged the unit for us. So we're not going to really see it frozen at this point. They said it was obvious there was frozen. They sent us pictures and everything. So I'm sure there was a freeze up here. So I'm just going to go inside here, make sure there's no more ice or anything. Coil's pretty hot here, so yeah, there's no ice on this coil. We're completely defrosted at this point. So let's start by checking out and seeing why it's not defrosting. So let's just pull this evaporator cover off. Just hit fast forward here, make things a lot quicker. All right, cover's off. So we're gonna go plug the unit back in. So when you plug the unit in, it actually defaults into a defrost, which is perfect for what I'm trying to accomplish here. So this unit has 3 heaters. There's one on the coil, there's one kind of on the what they call kind of the trough, and there's one in the drain. So let's start with the coil heater, 2.5 amps. So that heater's pulling good. And I'm going to move on to this drain pan heater now, or drain tube heater. So I'm not getting any amperage on it. So these have really low amperage. So what I'm going to do is wrap the wire twice inside of my amp clamp there. And let's see if we get any action now. Alright, so we're getting 0.16 amps, so that means divided by 2, it's really 0.08 amps. Alright, now I'm going to go ahead and take an amp draw, that trough heater, whatever you want to call it. So we're getting no amperage. I'm going to wrap it in twice again. Still no amperage. So I'm going to go disconnect the power. And I'm going to ohm out this heater here, so you got to disconnect one of the wires. You have to actually cut it. They use crimp, kind of the crimp connector type. So we're getting 1.4 mega ohm. So this heater is definitely done. Alright, I want to make sure the unit's cooling. So I'm going to time it. So what I'm looking for is every minute or every 2 minutes we should be dropping 1 degree. Obviously when we're at 50 it's going to drop quicker. I'm doing more of that test when we're getting closer to like below 30. So around 20, somewhere around there. Empty box, we should be 1 degree per minute. Sometimes it's 1 degree every 2 minutes. But let's see what happens here. So condenser fans running, compressors on. This coil's a little bit dirty, so let's get it cleaned out. The light's kind of shining through pretty good, surprisingly. Alright, so I'm at 38 degrees, 9 minutes in. Cooling a little bit slow. Let's clean this condenser fan and see if that helps at all. Yeah, we'll just hit fast forward here. So we're at 30 minutes. We've dropped 30 degrees, so that's good. So now I'm at almost an hour. I've been stuck at 12 degrees for a while here. So I'm going to gauge up. Okay. Ambient temperature 71 degrees. I'm getting 20 suction, 210 head. Alright, so we have a cap tube here. So that means we're going to take our desired temp and we're going to subtract 20 from it. So in this case we're looking for 0 Fahrenheit to -5 Fahrenheit. So if we take 20 away from 0, that's going to give us -20 Fahrenheit. And then if we go to -5, that means we're looking for -25. So we're looking somewhere in that range. So let's go pull up our chart here. Let's look up for -20. So -20 is right here. Let's go right to minus 25. And that gives us somewhere in the range of 16 to 12.7. So we're looking for 16 psi to 12.7, so let's call it 13 psi. Then our head pressure. So we're just going to go ambient plus 30 Fahrenheit. So 71 Fahrenheit plus 30 Fahrenheit gives us 111. So if we look up 111 Fahrenheit, have it right here. So we're looking for 276. So we're looking for 276 psi. All right, so currently our suction pressure is 20. Our head pressure is 210. We are looking for 16 psi suction pressure and our head pressure at 71 Fahrenheit. Ambient, we are looking for 276. So based on this, we have high suction, not by much, but our big hint here is we have low head. So high suction, low head equals inefficient compressor. All right, that suction pressure is really close, so I'm going to go ahead and pull the charge here. I'm running the vacuum right now. I just want to make sure it was charged correctly and non-condensables are not in there, although the head pressure was low. Okay, I'm just going to clean out this tubing really quickly just to rule it out as an issue for the freeze up. But as you can see, yeah, it's really clear. Okay, so we'll get this back into place and let's charge the unit up once we get to our 500 microns. Alright, so I almost have the full charge in there with equalize, so I'm gonna have to fire up the unit. Alright, condenser fan's running now, which means our compressor's running. So let's get the last little bit of charge in there. And we are fully charged now. Let's see if this suction pressure comes down at all. So we're going to start timing again. So we're at 42 Fahrenheit. And let's see if she drops down. Alright, so it's been 11 minutes. We've dropped about 15 degrees. So some slight improvement there, but this thing really should be coming down a lot quicker. And now we're getting some real hesitation here. And we have basically 20 suction again and 202 head pressure. So our suction pressure is high again, head pressure is low. And we're at the 30-minute mark. Not much action. It's been stuck at 14 here for a little bit, for about 5-6 minutes. You can't really see the timestamp there, but that's been about 10 minutes actually, looks like. And finally we're at the hour mark. We can't get below this 11 degrees here. It's been stalling out here for a while, so we have an inefficient compressor. Alright, so we have an inefficient compressor there, so it's super important that you know where your pressures need to be. So in this case, the suction pressure was only off by 3 or 4 psi. So usually when I see an inefficient compressor, the suction pressure will be a lot higher. Usually it fails 3 ways. The suction pressure is really high to the point where like you touch the suction line, it's hot, or the compressor is barely pumping. So just say the system equalized and we're at 50 and 50, it might pull down to 40 or 45, somewhere there. It's rare that I see it this close to what we're looking for our desired pressure. So I was kind of doubting it just for the fact of it was only off by 3 or 4. So that's the reason why I pulled the charge. I did a vacuum. You never know who's done what with the refrigerants, and funny stuff happens sometimes when you see those access ports on the system. You don't know who's been working on the system. So I made the decision to pull the charge and vacuum it down and recharge it, but our suction pressure came right back up to 20. So that tells us the compressor was inefficient.